pen, watch, bicycle, car, bus and bridge are all made of metals. On the other hand, helium, which makes balloons fly, and the carbon that constitutes diamonds are non-metals. What is the basis for distinguishing metals from non-metals? To understand the scientific basis for this classification, you need to examine the physical and chemical properties of metals and non-metals. In this lesson, you will learn about the properties of metals and non-metals. You will also learn how they form compounds and how they can be separated. At the end of this lesson, you will be able to define metals and non-metals, locate the position of metals and non-metals in the periodic table, discuss the physical and chemical properties of metals and non-metals, compare the properties of metals and non-metals. Metals are elements that have a tendency to lose electrons and form positively charged ions or cations. For example, sodium has an electronic configuration of 1s2, 2s2, 2p6, 3s1. During a chemical reaction, sodium can lose an electron to a non-metal like chlorine to form a sodium ion that has an electronic configuration of 1s2, 2s2, 2p6. Conversely, non-metals are elements that have a tendency to accept electrons to form negatively charged ions or anions. For example, chlorine has an electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p5. During a chemical reaction, chlorine can accept an electron from a metal like sodium to form a chloride ion. A chloride ion has an electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p6. To get an idea of the properties of metals and non-metals, let's first locate them in the periodic table. When elements are arranged in the increasing order of their atomic numbers in the periodic table, metals, including alkali and alkaline earth metals, are placed on the extreme left of the periodic table. Non-metals are placed on the extreme right of the periodic table. Based on the positions of metals and non-metals in the periodic table, it is possible to predict their properties. For example, the elements on the extreme left of the periodic table are metals that easily lose electrons and are highly reactive. On the other hand, the elements on the extreme right are non-metals. They readily accept electrons and are also highly reactive. You will now learn about these properties in detail. If you look around, you will find metallic objects around you in various forms. For example, jewelry made of gold and silver, wires made of copper, and curtain rods made of aluminium are all metallic objects. Metals are used to make these objects because of some specific physical properties. Let's take a look at some important physical properties of metals. All metals are solids at room temperature, except mercury, which is a liquid. All metals are lustrous. Metal surfaces shine when they are freshly cut. For example, gold and silver are popularly used for making jewelry because of their luster. Metals have high densities and therefore tend to sink in water. For example, tin and lead sink in water. Exceptions to this rule are lithium, sodium and potassium. The density of these elements is lower than that of water and hence they do not sink. Metals are highly malleable and can be beaten into thin sheets. For example, aluminium and zinc can be rolled into thin sheets. This property makes them suitable for use in various industries like construction and manufacturing. Metals are highly ductile and can be drawn into wires. For example, copper and silver can be drawn into thin wires. Metals are good conductors of heat and electricity. Copper wires are commonly used in electrical cables because of this property. Metals have high melting points. For example, tungsten has a high melting point due to which it is used in bulb filaments. Mercury is an exception to this property since it has a low melting point. Iron rusts because it reacts with moisture to form iron oxide, which is commonly known as rust. Metals react with other elements in a variety of ways. Let's look at some such reactions. Formation of ionic compounds. Metals lose electrons to non-metals to form strong ionic compounds. For example, sodium loses electrons to chlorine to form sodium chloride, which is an ionic compound. Action of metals with oxygen. Metals burn in the presence of oxygen to form metal oxides, which are basic in nature. For example, a magnesium ribbon burns in oxygen to form magnesium oxide. Action of metal oxides with water. Metal oxides dissolve in water to form basic metal hydroxide solutions. For example, magnesium oxide dissolves in water to form a strong basic solution of magnesium hydroxide. Action as reducing agents. Metals have a tendency to lose electrons. In other words, they are good reducing agents. For example, carbon in the combined form accepts electrons from sodium and gets reduced to carbon in the free state. Thus, sodium acts as a reducing agent. Non-metals show properties that are unlike metals. That is, they don't possess metallic properties. Let's look at the common properties of non-metals. Non-metals exist as solids, liquids, and gases. For example, silicon and carbon are solids. Bromine is a liquid. Chlorine, fluorine, and oxygen are gases. Non-metals are non-lustrous, that is, they have a dull appearance. For example, the surfaces of sulfur and phosphorus do not shine. Most non-metals have a very low density. For example, oxygen and nitrogen are lighter than air. The exception is diamond, a form of carbon. Diamond is one of the strongest known substances. This is because carbon, in this form, has a very high density. Non-metals are non-malleable. For example, sulfur and iodine cannot be hammered into sheets. Non-metals, except for carbon fibers, are not ductile. For example, phosphorus and bromine cannot be drawn into wires. Non-metals are bad conductors of heat and electricity. For example, sulfur and phosphorus cannot conduct electricity. The exception to this property is graphite, which is a good conductor of electricity. Non-metals have low melting and boiling points. For example, sulfur and phosphorus have low melting and boiling points. When you make a bonfire, the wood burns to release smoke. The burning of wood involves a chemical reaction called oxidation. The carbon in the wood reacts with atmospheric oxygen to form carbon dioxide. The carbon dioxide is released in the form of smoke. Let's look at the chemical properties of non-metals in general to understand their behavior with other elements. Formation of covalent compounds. Non-metals form covalent compounds by sharing electrons. For example, in a molecule of hydrogen chloride, hydrogen and chlorine share a pair of electrons. Thus, hydrogen and chlorine are bound together through a covalent bond. Action with oxygen. Non-metals form acidic or neutral oxides. For example, sulfur reacts with oxygen to form sulfur dioxide, which is acidic. Nitrogen combines with oxygen to form nitric oxide, This nitric oxide is neutral in nature. Action of non-metal oxides with water. Acidic oxides dissolve in water to form acidic solutions. For example, sulfur dioxide reacts with water to form sulfurous acid. Action of non-metals as oxidizing agents. Non-metals have the tendency to gain electrons. That is, they are good oxidizing agents. For example, chlorine accepts electrons from hydrogen and oxidizes hydrogen sulfide to sulfur. In the process, it liberates hydrogen chloride gas. Thus, chlorine acts as an oxidizing agent. In ionic compounds, the forces of attraction between the ions of metals and non-metals are very strong. Therefore, it is difficult to separate the elements in such compounds. You can overcome this force of attraction or decompose this compound by passing electricity through it. The process of decomposition of a substance by passing electricity through it is called electrolysis. To understand how metals and non-metals are separated through electrolysis, let's consider sodium chloride. On passing electricity, sodium chloride splits into sodium and chloride ions. Sodium metal is deposited at the cathode. The non-metal chlorine gas evolves at the anode. Metals and non-metals exhibit a number of differences in their properties. Some of these important differences are: metals are generally solids, but non-metals may exist in solid, liquid, or gaseous states. Metals have very high melting and boiling points, unlike non-metals. Most metals are malleable, ductile, and lustrous, while non-metals are not. Metals are electropositive, that is, they tend to lose electrons, while non-metals are electronegative because of their tendency to accept electrons. Metals are good conductors of heat and electricity, while non-metals are bad conductors of heat and electricity. Metals form ionic compounds, while non-metals form covalent compounds. Metals form basic oxides, while non-metals form acidic or neutral oxides.